Hello, everyone. Welcome to today's webinar, Dairy's Role in a Healthy, Sustainable Food System. Next slide, please. My name is Julie Matsanastro, and I'm Vice President of Dairy Experience Wellness here at Midwest Dairy. And today I'll be serving as the webinar moderator. As you may know, dairy foods play an integral role in today's interconnected food system. From the unique nutrient profile that nourishes Americans daily to the resource stewardship that dairy farmers practice. The purpose of this webinar is to shed light on dairy as a part of the solution to nourishing our people and maintaining the planet, while increasing awareness of dairy farming advances and commitments. Next slide. Before we begin, I'd like to cover a few housekeeping items. First, this webinar has been approved by the Commission on Dietetic Registration, CDR, for 1 continuing education credit for eligible registered dietitians and dietetic technicians registered. Certificates for this presentation will be shared via email following the webinar. Also, we encourage you to complete the post-event survey, which will also be included in the email directly following the webinar. Second, the webinar is being recorded and will be available for free and accessible for all interested listeners after this live event. You'll find the recording posted on midwestdairy.com in the coming weeks. And finally, we have time for question and answers today. So if you do have questions for the speakers, please type them into the chat box on your screen throughout the presentation, and we'll address as many as we can at the end. Now for our objectives. After this webinar, we hope that you will all be able to identify the ways dairy impacts sustainable food systems across health, environment, and animal welfare. Describe ways that the dairy community is advancing its sustainability commitments, and apply your knowledge of sustainable food systems as it relates to both planetary and public health. One last thing before we start, next slide please, is we have 2 questions that we'd like to ask you. So get ready to type your answer into the chat box. Our first question: what percentage of US greenhouse gas emissions come from agriculture? Is it A, 11%? A, 2%, B, 11%, C, 27%, or D, 35%? So please start putting numbers in. Ooh, I see a lot of numbers coming in. It looks like I see some 11, B, answer of B. Keep adding, please. Okay, I'm seeing answers coming in. Thank you. Let's go on to our next question. 1 serving of milk provides an excellent or good source of how many nutrients? Is it A, 5, B, 9, C, 13, or D, 15? Okay, I'm seeing different answers. How many nutrients are in a serving of milk? Seeing some 13 nutrients. Answer C, okay. Well, you'll have to listen really closely because these questions will be answered during our speaker presentation. So let's get on to meeting our speakers. We're so proud and pleased that these folks are joining us today. First, Dr. Joanne Slavin is a professor in the nutrition Department of Food Science and Nutrition at the University of Minnesota, where she teaches advanced human nutrition. With the help of current and former graduate students, she has authored more than 300 scientific articles on nutrition and the role of diet in disease prevention. Dr. Slavin is a science communicator for the Institute of Food Technologists and a member of numerous scientific societies, including the Academy of Nutrition and Dietetics and the American Society for Nutrition. In 2010, she was also a member of the Dietary Guidelines Advisory Committee. While she teaches at Minnesota, she grew up on a dairy farm in Wisconsin, which she still owns with her sisters. Next, Dr. Frank Mitloehner is a professor and air quality specialist in cooperative extension in the Department of Animal Science at UC Davis. He is also the director of the CLEAR Center, which brings clarity to the intersection of animal agriculture and the environment. His research focuses on understanding and mitigating air emissions from livestock operations, and he studies the implication of these emissions on the health of farm workers and neighboring communities. Dr. Mitloehner has served as the chairman of a global United Nations FAQ, Food and Agriculture Organization, partnership project to benchmark the environmental footprint of livestock production. And finally, Joan Maxwell. She was born a farmer's daughter in southern Minnesota and is now a dairy farmer herself. Cinnamon Ridge Farms is a family-owned, family-run farm located in Iowa. They get their name from the color of their Jersey dairy cattle. A winner of the 2019 Dairy Sustainability Award for Outstanding Dairy Farm Sustainability, Cinnamon Ridge Farms has implemented a wide variety of initiatives to care for their land and animals, some of which you'll hear about today. Over the years, the Maxwells have hosted tens of thousands of visitors on their farm to showcase their operations and tell their sustainability story. And with that, we'll turn it over for Dr. Slavin to kick off.
Thanks, Julie, so much for inviting me to participate in this. So this is what I'm going to be talking about: how dairy nourishes people throughout life with a focus on nutrition and health domain of sustainable food systems. You've already been introduced to me. Let's see. So you already have a background. That is me back in the day on our farm down in Lake Geneva, Wisconsin. I also want to appreciate all the people that fund our research. And we do a lot of broad research. Those are some of the scientific advisory boards I am on. So I teach nutrition. People need to eat to survive by choosing diets that optimize health. Nutrition guidelines tell us what types of nutrients, the amounts needed to maximize health, and nutrient requirements vary greatly over the life cycle and are most critical during growth and development. Back in 1941, Nutritional Sciences decided to issue recommended dietary allowances. And this is generally what people know about nutrients in nutrition: quantity of nutrients a person needed to consume daily to ensure basic good health, proper growth and reproductive success, and to prevent nutrient deficiency diseases. Most of our nutritional deficiency diseases have been eliminated in the US because of fortification and some of our food policies, but that could change quickly as we change our food supply. Things changed in 1977, and this is government politics. So all of a sudden, the US Senate Select Committee came out with the dietary goals, 1977, Senator George McGovern. And the underlying premise for this work was too much fat, too much sugar, salt can be and are linked directly to heart disease, cancer, obesity, and stroke, among other killer diseases. Unfortunately, there were no scientists on this committee, so all of a sudden nutrition shifted. And if you go from there, 1977, in 1980, the dietary guidelines for Americans were born. And they basically are this idea of what's the relationship between exposure to diet and chronic disease. On the left here is the dietary reference intakes that we talked about, the science of how much nutrition, what nutrients do we need to support good health. In the middle are the dietary guidelines for Americans. And that orange book is from 2010, when I served as the science advisor for the Dietary Guidelines Committee. Remember, though, the dietary guidelines come out every 5 years. They are in the budget, which is really nice. So they will happen every 5 years. But that document there, Dietary Guidelines for Americans, is jointly developed by USDA and Health and Human Services. And the people that are on the science committee have no role in it, really, besides providing the science background. So, and then we have to put it on a plate so we can put it into practice. So once we have the dietary guidelines, we will have this plate which says how many servings do we need from different food groups. So these are the dietary guidelines from 1980 to 2005. And if you look really from 1980, they have stayed the same. So the things that we're going to talk about, there's been a ton of change. There's just been kind of more putting numbers on those recommendations. 2005, whole grains came in. There was something on trans fats along the way, but really hasn't changed too much. What do we do on the Dietary Guidelines Science Committee? We have to look at update all the science, which is a huge amount of work. So getting a diverse group of people on that committee, systematic reviews are useful, but we cannot get away from the dietary reference intakes. If we have to make some changes in the diet and we are not going to be able to get nutrients, we always have to go back and worry about that and make sure that we don't make a mistake like that. And then also diet modeling being important. So Health and Human Services and USDA uses that technical report and then develops the dietary guidelines. So this is the most recent: healthy eating pattern, variety, nutrient density, and amount, added sugars, solid fats, and reducing sodium. Those are the things we want less of. Shifting to healthier choices and healthier eating patterns for all. Healthy patterns really are exactly what we talk about, what's on the plate there. But importantly, there are 4 nutrients of concern that always come up. We don't get enough calcium, we don't get enough vitamin D, we don't get enough potassium, and we don't get enough dietary fiber. And those are things we need to continue to work on. We see that there's these healthy eating patterns that we're recommending the foods, but we cannot lose sight of the nutrients. So when people say the dietary guidelines don't matter, they truly matter a lot. So here we have all of the things that are affected by the dietary guidelines: policy, marketing, label, reformulation, nutrition education. So over on the left, if you look at the SNAP program, the WIC program, National School Lunch Program, all of those have to follow dietary guidelines. So when dietary guidelines change, there's changes. We're going to make sure those get updated. Labeling, the nutrition facts label has been changed because of the trans fat things, added sugar, all of that. As soon as there's a recommendation in the dietary guidelines, you need to shift that nutrition facts panel, and then just education. The 2020 dietary guidelines, this isn't that different. It was just a different way of showing it. Healthy dietary pattern at every life stage. Make sure you get nutrient dense foods, and make sure that you care about people's personal preferences, cultural traditions, and budget. And then this idea of nutrient dense foods and beverages staying within calorie needs, and then limiting foods high, those ones we talked about: added sugar, saturated fat, and sodium. And some of the highlights of 2020-2025 is life stage and dietary patterns approach. But for the first time, we started talking about under the age of 2. So pregnancy, lactation, and infants and toddlers were included in dietary guidelines, which is a huge new important thing that has gone into the dietary guidelines. Added sugar and saturated fat stayed the same, alcohol stayed the same, but just this references to make sure that we think about people and we don't have recommendations that don't fit into their life. So this is a new recommendation for the first time because we were looking at infants and toddlers. So recommending at 6 to 12 months, cheese and plain yogurt, and then in the 12 to 23 months, whole milk and reduced fat cheese, but not recommending flavored milk, avoiding added sugar. So trying to make sure that we follow the recommendations of the dietary guidelines. It's important, though, that when people say, let's get dairy off the plate, consumption of dairy foods provides numerous health benefits. So we have a lot of health recent research showing that dairy is associated with health, but also what we find is that dairy contributes most of these nutrients of concern. So 67% of calcium, 64% of vitamin D, and 17% of magnesium. So really important to make sure those get into the diet. I also wanted to mention just about building healthy eating patterns. So often people say, oh, the dietary guidelines provide no flexibility. But this is how you actually, USDA is very good at saying, okay, this is the recommendations we have, and how are we going to actually put that into the foods? So building these diets up. So in the middle here, you see USDA food patterns and the number of cups and servings of these different groups that we've already talked about. But there are other options that are listed in the dietary guidelines. So if you want more of a Mediterranean eating pattern, there are recommendations for that. The DASH eating plan, which is the dietary approaches to stop hypertension, also fits well into this. And they also have done USDA vegetarian adaptations that you'll see down below here for both lacto, ovin, and vegan. Obviously, as we change these diets up, we have more problems getting some of these nutrients in. So we have to say you must have calcium fortified soy milk to make sure those nutrients of concern that you're not getting by not eating dairy are brought along in those diets. I want to really talk a lot about protein because I believe, even though it's not a nutrient of concern, there is a real emphasis, people going more to plant-based diets. And I work in dietary fiber. I'm a big supporter of plant-based diets, but I'm also concerned about protein. So we know that our RDA for protein is 0.8 grams of protein per kilogram body weight per day. So we also have this acceptable macronutrient distribution range of 10 to 35% of our calories should be from protein. And when people get into nutrition, they're like, that seems ridiculous. Why would it be so broad? But if you are on a really low calorie diet, which a lot of Americans need to be on because of obesity and concerns about that, you need a much higher percentage of your calories as protein. So if you're on a protein sparing modified fast, obviously that's going to be all protein and you will not have carbohydrate or fat in that diet. So you need to eat this higher percentage of calories from your protein, and you also have to choose high quality proteins. And there's a huge difference in protein quality between animal proteins and plant proteins. So just so people, and generally about 3/4 of people in the US get most of their protein from animal products. So protein isn't a nutrient of concern, but as we change the diet, we need to be concerned about that. Also, growth, pregnancy, lactation, protein needs are higher. And we also have a lot of interest now in the elderly and loss of muscle loss or sarcopenia. So the elderly may need higher protein diets and higher quality protein diets. This is from my class, and this is my textbook that I like because everything's on the plate, and then we put it onto these bars. Where do we actually get this stuff? So protein is part of the purple part of the plate is protein, and you can see some of the big sources in there of protein. So obviously beef, chicken, eggs, salmon are big sources of protein and high quality protein. Other sources, beans, tofu, peanut butter, also protein sources, seeds. But the dairy group has its own separate group. And the dairy group is blue. And as you see, it also has a ton of protein. So the beans can go between the vegetable group and they can go between the vegetable and the protein group, but dairy is in its own group because of the need for calcium and vitamin D. But each serving of dairy, 8 grams of high quality protein. So important as we change our diets, and don't forget this protein isn't a problem now, but it could easily become one as we don't have that on our plate. Also cost. We do a lot of, we've done a lot of research thinking about different sources of milk. And here just, if you were going to fill out the quiz and say, okay, what does dairy bring along? Obviously, calcium and vitamin D are incredibly important. Riboflavin, vitamin B12, also potassium, another nutrient of concern, vitamin D, nutrient of concern, phosphorus, vitamin A, niacin, pantothenic acid, selenium, zinc. So if you pick the right answer, you can count those up and say, wow, one serving of milk is a great nutritional drink to put on. And most of these other beverages that people are using don't have, they don't bring the nutrition along at all. So the protein quality is not there. There's no protein. A lot of these beverages only have about 1 gram of protein as opposed to 8 in a glass of milk. If you look at cost too, cost is an important topic in nutrition as we want to make sure people can afford high quality nutritious foods. You'll see the difference, just 20 cents per serving for dairy, and some of these other products 2 to 3 times more. So just dairy is more economical than these plant-based beverages, and definitely brings a lot more nutrition along. I think a lot around the world, growing up on a small dairy farm, my dad would always say, get a job where you work inside, and then we will never starve to death. We have chickens, we have cows, and that's for people that have lived through the Depression, having, being close to your food supply and being able to milk your cow, feed your cow, and have milk every day. It's pretty amazing. So this is some data just to point out that dairy in the US sometimes we forget because it's so readily available, but around the world, dairy has a role in reducing hunger globally too. And in rural low income settings, household milk production increases milk consumption, and increased milk consumption results in improved child growth and reduced stunting. So around the world, as soon as people find out, the dairy products are so high in nutrition and are accessible to them, really does help for hunger globally. I want to finish up on just trying to get out good nutrition information. My first job was in extension, and I love talking about nutrition and telling people, hey, moderation and variety is where it's at. There's no one food you have to eat, but when you put moderation and variety together, you can get all the nutrients you need by getting this variety of foods, not over consuming any one part. In 1916, USDA started with food for young children, and still most important that during growth and development, all these nutrients have to be available for us to be successful and to be healthy. So no question, as we moved along, we need to focus on food for young children. In the 40s, the Basic Seven kind of got into this idea that there's all this food that we need to get. And if you read in it, people say it's kind of historical, but they said if you're going to use margarine, make sure that it's fortified with vitamin A and vitamin D, nutrients that come in through the milk supply. So it was back in the 40s, a ton of interest in nutrition and actually understanding food composition. So we go forward the 50s, 60s, and 70s, Basic Four, probably what you learned about, pretty similar to where we are. We need to get these variety of foods because they pull together the nutrients we need, vitamins, minerals, proteins, all these nutrients we need. And then this idea that we don't need too much of these extra calories. So 1992, I think is good just because it shows some scale, that up on the top there are solid fats, added sugars, alcohol. These are extra calories that we need to get out of the diet if we're worried about obesity or we have an obese nation. But we can't get rid of that food supply down on the bottom there too. 2005, we have the guy running, which is important, but kind of a difficult concept. So since 2011, we have had My Plate shown here. It was introduced in 2011, and it is the most recent food guide. Shows about how much of your plate should be filled with various food groups. Now, we've already talked about the protein group, obviously the purple group, the grains group, half of it should be whole grains, and then the fruit and vegetable group, a variety of bringing through nutrients, and the dairy group. And basically the dairy group is there because both vitamin D and calcium, nutrient of concern, so front and center. So I think dietitians, other people get that. But then I was up in Canada, and Canada has a food guide that came out in 2019 that looks kind of almost exactly like the US My Plate. And we do share the dietary reference intakes with Canada. So there's a lot of coordination. But the point here is they said, well, we got rid of the dairy because make water your drink of choice. And this is the hard thing about explaining nutrients coming through with foods and just, foods versus beverages, that dairy should really just be another piece of the plate over here. It's not that we're saying you need to drink milk, you need to eat dairy products to get those nutrients of concern. And every time I talk to my friends up there, they say, hey, that's yogurt. And I said, it looks an awful lot like ranch dressing to me, but let's believe that, but that's not enough servings in the day for you to get those nutrients that we need. So I want to conclude and thank you for your attention. We have to provide dietary guidelines across different age groups and from birth to death. So we have a huge charge of through life cycle nutrition to make sure everybody is getting the nutrients they need. Most of us don't eat that many calories, or we shouldn't be eating that many calories, so we cannot afford foods that are high in calories. So nutrient dense things, dairy products. And that's really why low-fat dairy is recommended, is you take the fat out, you get the calories out for people that need to reduce, but it doesn't affect the nutrients. We just need to get dairy into everybody's plate. Whole grains, fruits, vegetables, and proteins will always be on the plate in any type of dietary recommendation. The dairy group is critical to vitamin D and calcium for sure, because those are two nutrients of concern, but it's, in my opinion, it should also be part of the protein group, as each serving provides 8 grams of high quality protein. And when you look at trying to provide protein to the wide group, that's incredibly important. Other things we can't forget as dietitians and nutritionists, that cost. We are really fortunate in the US to have a very inexpensive food supply. and a very efficient food supply. And every time something costs a lot more, it will affect us. So we need to be concerned about that. Sustainability. This is why we're here today. That I find it, as growing up on a farm and still being in the farming business, I feel like we've always been sustainable. We care greatly about our animals. We care greatly about our land, and everything we can do to make it more sustainable for the next generation, we're obviously on board. Supply. If there's no supply, during COVID, we realized that could be a problem. We need to work on that. Culture. A lot of things that we don't know. People eat insects places, they eat guinea pigs, and we're like, oh, I would never do that. But those are good sources of protein, and we need to think about that when we give out this recommendation. But in general, people don't know how to cook anymore. So even though we say we don't want processed foods, convenience are really important for most people. So as we think about that, when we're doing dietary guidance, we cannot just give it for the rich people. We need to give it across all rural, everywhere we go, we need to think about what works for people. But I always end up with this, that food only provides nutrition when it's consumed. So if you try something and nobody eats it, you haven't accomplished anything. So we have to be mindful of overzealous rules on sodium, added sugars, and solid fats. When they take out foods that people normally consume, that they won't be able to consume anymore because of these rules that seem really inflexible and not helpful. So flavored milk, full fat milk, yogurts, cheeses, whatever reason we're taking them out of the diet, it really does affect the nutrients that comes along with dairy products. And we need to be concerned about that, especially for people that are the most food insecure in our country. So I appreciate your attention. Thank you so much.
Thank you, Dr. Slavin. And next we'll hear from Dr. Mitloehner.
Good morning, everybody. It's my pleasure to present to you a few slides around the impact that dairies have on climate and why managing methane from livestock can be part of a climate solution. Now, I was introduced as Frank Mitloehner, and I'm a professor, and I have been here for 20 years at the University of California in Davis. A couple of years ago, I established a center called the CLEAR Center that has really two cores. One is in research, one in science communication, and we are quite active with respect to science communication in particular. Today, I will talk to you about one gas in particular, because in my opinion, it's the Achilles heel of animal agriculture, particularly when it comes to the concerns society has around a changing climate. That gas is methane. So I start out by explaining briefly what greenhouse gases such as methane do and why they are considered an issue. What this slide shows is the sun radiating down solar beams to the surface of the earth. And normally that solar radiation, and with it the heat that radiation encompasses, would be reflected back into space if there weren't a blanket of greenhouse gases. And like any blanket, this blanket too holds the heat from the sun back in our atmosphere. And that's actually a very important function. Without these greenhouse gases, life on Earth would be too cold for us to live here. So we need greenhouse gases. The problem, though, is that we produce too many of those. And that just makes this blanket too thick, and therefore too much solar heat is retained in our atmosphere. So while most climatologists will tell you that the main greenhouse gas of concern is carbon dioxide, which is a function of burning fossil fuels such as oil, coal, and gas. Many, particularly in the anti-animal agriculture arena, will say we should focus on methane. And so that's where a lot of the discussion stems from. I want to be clear and on record as saying methane is a very important greenhouse gas and we need to reduce it. But we also need to get the nuances right. And today is my attempt to get us there. Just really quickly, with respect to greenhouse gases in a country like the United States, what is the contribution of agriculture overall? It's about 11% of all greenhouse gases that stem from agriculture. And that's according to the Environmental Protection Agency. The same agency says that animal agriculture is responsible for 4% of all greenhouse gases. But the remainder, so the difference between the 11 and the 4, contains also, of course, crops produced to feed animals. So But just to give you a general idea, so the contribution of animal agriculture with everything included might be around half that of all agriculture. So when we look at greenhouse gases, such as carbon dioxide, methane, and nitrous oxide, and we compare them to each other, then most often a means of comparing is used called global warming potential. That's called a matrix. The global warming potential 100 is the one that says that one molecule of methane is 28 times more capable of trapping heat from the sun than one molecule of CO2. And nitrous oxide, even more so, 265 times more potent. Now, the best analogy I can give you is keeping your coffee warm in the morning. You can put it into a styrofoam cup or into a China cup, or you can put it into a Starbucks $20 insulated cup. The same coffee goes into those 3 beverage containers, but depending upon what cup you pick, the coffee will stay warm different length of time. So the same is true for solar heat retained by these molecules. Methane is much more potent than CO2, and nitrous oxide tremendously more so. So this GWP 100, global warming potential 100, has been used for the last 30 years to describe the impact of methane and nitrous oxide on warming and comparing it to CO2. Now, this matrix GWP 100 is under criticism, and I will tell you why. Before I do so, let me show you a pretty important slide, this one here. It shows the global methane budget. The global methane budget shows on the left side that there are various sources of methane, including fossil fuel production and use, agriculture and waste, biomass burning, and so on. And you see the top left half bubble summing all these sources up as 558 teragrams. And so that's a large amount, and that's normally what you see in the media. What the media doesn't report is that they're not just sources for methane, as the ones I just described, but there are also sinks for methane, and they are listed on the right side. The sinks that exist amount to 548 teragrams. In other words, 558 are produced and 548 are destroyed globally. And that leaves the difference, which is 10, still a number we seek to reduce, but certainly one that's very different from just looking at the sources. So remember, methane is the only greenhouse gas that's not just produced, it's also destroyed. So we need to deal with the difference between these two. On the right side, under sinks, you see a large arrow pointing down, and it says 515. And underneath it says sink from chemical reactions in the atmosphere. What does that mean? That means that when a methane molecule makes it into the atmosphere, it stays there for approximately 10 years. And then it meets another molecule called a radical, and this radical destroys the methane. And this radical, also referred to as a hydroxyl radical, does so pretty effectively in approximately 1 decade. And that is really important when describing what the impact of methane is on climate versus what the impact of other gases is on climate. And again, methane is the Achilles heel of animal agriculture. That's why it makes so much sense for you to learn these basics. What I just described, the fact that methane is not just produced but also destroyed, leads to the following. Namely, the lifespan of these gases is very different. When you drive your car, you burn gas. That leads to the emissions of CO2 from the tailpipe of your vehicle. That CO2 will stay in the atmosphere for approximately 1,000 years. Nitrous oxide stays in the atmosphere for well over 100 years, and these two gases, CO2 and nitrous oxide, are referred to as long lifespan gases. And that's in contrast to methane, which stays in the atmosphere for about a decade. It's a short-lived climate pollutant. So methane is not the same as the other gases. It is true that it's more potent than CO2, but it's also true that it's very short-lived. And that's why I call it the fast and furious greenhouse gas. It is the most important greenhouse gas in animal agriculture, and that's why we really have to pay attention to it, and we certainly do. Now, when you compare two sectors, let's say the fossil fuel sector, which by far produces most greenhouse gases, particularly CO2 and methane, versus the agricultural sector, then you will see quite some differences. Let's start on the fossil fuel side. So fossil fuels are oil, coal, and gas. And on the left side, you see that's ancient carbon that was in the ground for a very long time. Over the last 70 years, 70, humans have taken about half of all that oil, coal, and gas. So all of that fossil carbon out of the ground. We extracted it, we pumped it, we dug it out, we burned it with cars, trucks, trains, planes, ships, adding new and additional carbon to the atmosphere. So that's what you see on the left side, a one-way street from the ground up into the atmosphere. Now it gets more complicated on the right side. What you see there is the so-called biogenic carbon cycle. On top there, you see CO2. That's CO2 in the atmosphere. Some of that CO2 is taken on by plants, like this forage this animal consumes. So plants during photosynthesis take on carbon in the form of CO2. Some of that carbon stays above ground, is made into cellulose or starch, but the majority of the carbon that came from the atmosphere is actually making its way into the roots. And from there, soil microbes take that carbon and incorporate it in the soil, a process called soil carbon sequestration. It's a very important process because healthy soils are believed to trap about 1/3 of all human-caused CO2 from the atmosphere and store it for a long time. So on the right side, you see a bovine there. And obviously, that animal will eat above-ground vegetation. And when it does so, microbes in the rumen will produce methane, and that methane will be belched out. That's the CH4. But within 10 years, that methane is converted back to where it originated from, CO2. What I'm saying here does not mean that the methane doesn't matter because it's part of a cycle. But what I'm saying here is on the left side, on the fossil fuel side, you have a one-way street of carbon from the ground up into the atmosphere. And on the right side, you have a cycle from atmospheric CO2 into cellulose and starch into the soil. But then also the animals consume vegetation, the microbes produce methane, that methane becomes CO2. This is not a one-way street, but it's a cycling of carbon from one form to another. And that's an important distinction I hope everybody sees. So when people compare cars to cows, they are really not doing themselves or anybody else a favor. They are misleading people to believe that these are comparable, which they aren't. So I will now talk to you for a few minutes about the difference between two more very important gases. The one is CO2. And again, that's, for example, produced when you drive a car. So let's say on Monday, you drive your car from home to work. When you do so, you burn that gas and that produces CO2. So that's on day one. On day two, you drive the same distance and you will produce an equal amount of CO2 into the atmosphere, which is now in addition to the existing stock from the previous day. On Wednesday, day 3, you drive again and you do the same thing. You put new additional carbon into the atmosphere. Every time you will ever burn fossil fuels, oil, coal, and gas, you will add new and additional carbon to the atmosphere, causing new and additional warming to our planet. Currently, methane is treated as if it were to behave the same way, as if every time our cows belch, let's say, that methane were to accumulate, just like CO2 accumulates. But I already told you, methane is not just produced by sources, but there's also a sink for methane, namely this process called oxidation, done by these radicals I talked about earlier. And what that means is that if you have a constant source of methane, then you find that an almost equal amount of methane that's produced is also destroyed. A near constant source, let's say a near constant herd of cattle, will not add additional warming to our planet. The nuance here is very important. I repeat that. A near constant methane source does not add additional warming to the planet. Why does the additional matter? Because that is what the world is after, not causing additional warming beyond 1.5 to 2 degrees centigrade. That's what the Paris Climate Accord is all about. That's what we should all focus on, not causing additional warming. Now, can methane cause additional warming? Yes, but only if you increase over time. Let's say if your herd size increases from 100 cows to 150 cows to 200 cows, then over time you will have increased methane. But if your cow herd always was 100 cows, then you have not increased methane and you have not increased the resulting warming. Now, this was first discussed by University of Oxford scientists from the UK around Miles Allen, and it has really changed our way to think about methane. Remember, CO2 is a stock gas. It accumulates in the atmosphere, whereas methane is a flow gas. It does not accumulate, but it's both produced and destroyed. As a result of that, those colleagues from Oxford said the way we are quantifying the impact methane has on warming is wrong, because we need to treat methane as what it is, a flow gas and not a stock gas. They said years ago that the old way GWP 100 that has been used for the last 30 years, when that is used for characterizing a constant source of methane, then we are overblowing the impact of that constant source on warming by a factor of 4. I have said it for years, but it took a while for people to understand until recently, and you will see that in a minute. Oxford University developed a new way of characterizing the impact of methane called GWP star. And that GWP star actually takes into consideration the short lifespan and the fact that this gas has an atmospheric removal. The IPCC, the Intergovernmental Panel for Climate Change, in its report that came out in 2021, finally agreed with this criticism and stated on page 123, and I'll read that for you because it's so important, expressing methane emissions as CO2 equivalent emissions using GWP 100 overstates the effect of constant methane emissions on surface temperatures by a factor of 3 to 4. So in other words, the way that methane has been quantified for the last 30 years using GWP 100 is overblowing the impact of constant sources on warming by a factor of 3 to 4. And in my opinion, our dairy industry falls into that very category. So now I will briefly just point out that CO2 and methane, described here on the top, in the first case as rising, then as constant, and then as falling emissions, have very different ways in how they affect warming. I will not go into all the details, but what I want to show you is this. On the right side, if you decrease CO2, let's say a power plant over time produces less power because they want to shut it down eventually. What happens when you reduce CO2 over time? The bottom panel on the right shows that even if you reduce CO2, the related warming still goes up. And it continues to go up, the warming continues to go up all the way until the point when you shut down the burning of oil, coal, and gas. And then at that point, you are plateauing the related warming. But look at the blue lines. What happens when you reduce methane? The bottom shows when you reduce methane, then you reduce warming. I repeat that. When you reduce methane, you can reduce warming, and instantaneously so. And that puts us in animal agriculture in a situation where if we reduce methane, we become part of a climate solution. We can actively pull carbon from the atmosphere, much as if we were to plant trees. So a reduction of methane can really make a difference, and we have the tools to achieving that. I will now show you briefly a comparison of this old GWP 100 to the new GWP star matrices. What you see here are 3 scenarios. The first one is one where methane is increased over 30 years by 35%. Second one is where methane is pretty much kept constant. And the third one is one where methane is decreased by 35%. GWP 100 would say that in all 3 cases, we're adding a lot of additional warming. Regardless of whether we increase, hold stable, or decrease methane, the related warming still goes up by a lot. And GWP star disagrees with that. Yes, if we increase methane, we increase additional warming. That's the blue north of the x-axis. But if we slightly reduce methane, then you don't see any blue north of the x-axis, but because it's a 10% reduction over 30 years, we see a slight reduction of warming. negative warming. Some people call it, and you see it here at the bottom left, cooling. I don't call it cooling, but some people do. I call it negative warming, because what it means is we are reducing warming when we reduce methane. So the question is, can this be done? You might ask, is it possible to reduce methane by 35%? Well, yes, it is. Here in California, we have probably the strictest, not probably, we have the strictest methane law in the world, mandating 40% reductions of that gas to be achieved by the year 2030. A few years ago, that law passed, but our legislature was wise by not using the cane approach of rules and regulations and fines, maybe taxes to achieve that 40% reduction, but to use a carrot approach of using a voluntary and incentive-based approach to reduce emissions, meaning help farmers to put in technologies to reduce emissions. Our farmers have done that. Many farmers have done it. What you see on this slide here is a former lagoon. It used to be open, now it's covered. And what's bulging out there is the so-called biogas, 60% of which is methane. Now, in the past, people have always viewed this methane as a problem. But this methane is nothing other than energy. It's only a problem if you just blow it into the atmosphere. But if you utilize it, it's the same as natural gas. So what these farmers here do now is they take this biogas that's trapped from the covered lagoon and they convert it into transportation fuels for heavy-duty trucks and buses. So many of our farms have done what I just said, that we have already achieved 30% of their dairy sector's methane reduction goal. We need to reduce 7 million metric tons. 7 is the number. We have already achieved 2.3 million metric tons. And this whole thing just started a few years ago. In addition to this, so here you see what it looks like when you take dairy renewable natural gas derived from those covered lagoons and you put it into heavy-duty trucks. In addition to what I just said, using manure treatment and manure technologies, we can also use feed additives that have a significant potential to reduce enteric methane, which is the methane belched out by cows. Soon, in next month, we'll have an international summit here at UC Davis with USDA, with California agencies present, as well as folks from all the way over Rome, Italy, from the United Nations FAO, discussing feed additives. So really quickly, California case study, I have 2 more minutes. I told you our goal is to reduce about 7.2 million metric tons of this methane, and we have made great progress. If you take a photo of this QR code, it will get you to a report that we recently have submitted to the legislature. We are well on our way of reducing methane by 40% in our dairy sector. And it is almost too good to believe, but the 7.2 million metric tons, which appear to be unachievable, will be achieved. And we have a combination of different approaches. Here you see several of them. We have a slight reduction of herd size year after year of about 0.5%. We have these anaerobic digesters. We have some alternative manure management practices, and in the future, some enteric additives. Cumulatively, they will reduce methane by 7.6 to 10.6 teragrams or million metric tons. Sorry, 7.6 to 10.6 million metric tons. Again, the goal is 7.2. We will overachieve. And we will overachieve this without breaking the bank, because our legislature, our state has decided to work with our dairy farmers hand in hand. So with that, I will not talk about this in any greater detail here because of lack of time. I'm on Twitter. GHG Guru is my handle. My center, the Clear Center, is on Twitter as well. And we are writing many blogs and explainers and so on, which you will find on the Clear Center webpage. clear.ucdavis.edu is the address. Thank you very much for your attention. I'm looking forward to having our discussion. Thanks.
Thanks, Dr. Mitloehner. Again, just a reminder to, if you do have questions, and we will have time, to please add them to the question and answer section, and we'll be able to have those addressed to our speakers. So thank you. And with that, our final presentation today is from dairy farmer Joan Maxwell. Take it away, Joan.
Well, good afternoon, and welcome to our very cold and windy day here in Iowa. We're looking forward to spring. Like I said, I've been a dairy farmer just recently, but I grew up a farmer's daughter in southern Minnesota growing row crops, and we've seen quite a lot of change in my generation of farming. Here's some of our dairy cows out on pasture, but we are a 5th generation dairy farmer. We're located fairly close to the Mississippi River. And as we said, we do quite a bit of tourism, and some of our tourism is driven by the Mississippi River with the river boats coming up the Mississippi. Just waiting for my ability to switch to the next screenshot. One of the things that you've heard much from our previous speakers is the circularity of agriculture. We grow our crops, we feed our crops, and then we take the waste, which is the manure, and put it back on the soil. I am unable to go to the next screen. Could you advance it for me, please? Oh, now I got it. Okay. So as you can see, we grow the crops for our cows. Our cows eat the crops and they produce the milk and they produce the manure. We apply the manure to the land and we grow the crops to feed the cows again. So one of the things when we're looking at our soils, everything starts with the soils, is just like the Maslow's hierarchy of needs. There's got to be some basic things that we need to be able to do before we can get to the next level. We need to make sure we have proper drainage. Our soil pH needs to be well, our potassium and our phosphorus. And as we move along, everything starts with the soil sample. We have over 30 years of soil sample history on our farms. You don't know where you can go if you don't know where you've been. And this is what a sample of a soil sample looks like. We do ours on a 2.5 acre grid, and we sample for macro and micro. And also with this, you've probably heard the word precision agriculture. Well, this is the first step in precision agriculture. And one of the things we look at is yields. We want our maximum yield using the minimal amount of resources possible. And above all, we want clean water. We drink the water, and also from a financial point of view, we don't want to see our inputs going down the river and ending up in the Gulf of Mexico. We want to keep our inputs, our fertilizer, our nutrients here on the soil. So one of the new things that you're hearing about is called a cover crop. Now, many of you may not know what that is, but we've been doing cover crops since the mid-'80s, before it was a thing. And what a cover crop is we plant this into the harvested field. Now this over here is a field of silage that was taking off in September. We drilled rye into it. It starts growing, and then in the spring, or during winter, it goes dormant, and then in the spring it starts growing again. And this is a picture of the in the spring. The benefits to a cover crops is due to the weather events and melting snow and just normal rain that we get. The roots will hold that soil in place. And also the other part of it is the cover crops will utilize any excess nutrients that weren't used by the previous crop. And this will keep the soil in place. It keeps the nutrients locked up, which then keeps it from going into our local water system. And in our case, our watershed is the Mississippi River. The other benefit of the cover crop for us is it becomes a feed source. And here is what it looks like in the spring. We'll be harvesting this around Memorial Weekend or so. And this is rye, triticale, wheat. Any of these will work. And we harvest it green. And this becomes a really nutritious feed for our cows. Plus, it keeps the soils locked up. And then we harvest it and we ensile it, which is an anaerobic process where it ferments the crops and keeps it from spoiling. We put it in the sacks and then we end up feeding it to our heifers. Then you've probably heard terms like no-till. What that actually means is, there's a picture of our tractor and planter, and we are planting the soybeans right into the cover crop there. I mean, we didn't work it and it grows right into it. And actually there was no chemical kill to this as well. This is what it looks like a few days after we've harvested it. Now, the next that we do is we'll get yield maps when we harvest our crops, not particularly on a cover crop harvest, but on our corn and soybeans and if we harvest wheat or rye as a grain. And what this is looking at, and if we can put it over the top of a soil sample, you'll see how many of these things overlap. You can tell where the hills, the knolls, and various things. It's telling us our soil samples, it's telling us where our yield deviations are, as well as what the yield was and the moisture content. So we get a lot of information from our maps, but it's just one map, it's just one piece of data. We add more data to it. We also do a lot of field trials on our farm. It is very difficult as a farmer to decide, I'm just going to go with this practice or with this seed. We only get basically 40 harvests in our lives. And one decision, one bad decision can be very detrimental to us. So we do field trials, meaning we'll take a field, put different varieties on it, or we will do one field and split it in half with one practice and with another practice. Here's an example of some of the field trials we do, which is which corn is better for the cows and which is better for us. And what I've got highlighted here, it may be hard for you to see, but it's the pounds of milk produced per acre. And over here on the left where it says product, that's the different hybrids that we use on the farm and the different seed treatments that are included with it. And as you can see, it's ranked, and we go with the various ones that produces the most milk per acre. That's the most efficient, and that is also the most profitable for us in that case. And that's, again, just one piece of data. However, it all comes down to the cows. Our cows don't produce for us unless they are comfortable. The more comfortable the cow is, the better that they produce. And there's one of our lead cows right now, Cheddar. She's one of our award winners here on the farm, and she also likes to mug for the shots. Some of our comfort is we bed with sand. Like I said, we're not too far away from the Mississippi. And so we can get sand very easily, fairly low cost for us. It's kind of like the Jersey Shore. Our cows are Jerseys and they like to lay on it. It's the most comfortable. And we also have back scratchers and head scratchers, anything to make the cows more comfortable. The other thing that's unique to us is we milk with robots. That is where the cow comes in all on her own, and the robots hook up, or the milkers hook up automatically using lasers and technology. And then they go off and eat and go lay down, and they come in and get milked when they want to. Again, this is all cow comfort and efficiencies and what's best for the cows. For some of you may be curious about what kind of things do we see on our robots. Well, this was our dashboard on our robot a few days ago. So we get over 120 plus data points every day on every cow. And what you're looking at is this is the dashboard. And from there, we can drill down and get down to the specific cows that made up that information. But at a glance, it tells us what's going well, where do we have some concern, and where do we need to look at. We also have a feeding system here that I can get down to the cost per pen on what our feed is like. And then we can merge this with our robotic data and come up with how much each individual cow is eating, down to what happens if we change an ingredient. Within 24 hours, we can tell through our robotic data on the milkers, what kind of effect did that have with our individual cows. So it comes down to, if we change this, did it create more milk fat? Did it increase the milk production? Did it decrease the milk production? And then ultimately, was it worth making the change on a financial point of view, or by observation of how did the cows react to a particular change? What we've recently started is the use of AI, artificial intelligence, to tailor the milk schedule to the cow. One of our constants is each time the cow comes into the robot, there's a specific amount of time that is used for the robots to hook up. That's a constant. It takes time to scrub the teat. It takes time for the lasers to come out and hook up. And then the amount of time and then the thing that can change is the amount of time for actually the cow to milk out, depending on how much milk she's producing at time. So we did this hypothesis is basically, if we can go the longer amount of time between visits, cow goes through fewer, will that be more beneficial for the cow? Is it more beneficial for us? And we found out that we could get more yield per cow. It was better for the cow. We're getting more milk through the robots per day. And as a consequence, we were able to increase the number of cows we milk by 10. And that is huge when it comes down to the efficiencies and utilizing our barn to the maximum. And the other part of the constant is it takes just as much time to feed the cows if you're feeding 10 or if you're feeding 10 less. And so that's using less fuel per cow because we're able to spread it out over more cows. One of the things we haven't touched on is cows are a great upcycler of things from other products. Our cows, I have a picture here of, well, we have the cover crops. Our silage is the whole corn plant. What I'm holding there in my hand is cottonseed, which is a byproduct of cotton production or making clothing. Soybean meal is a byproduct of soy oil or vegetable oil, where most of that is used for human consumption. Well, we can use the offshoot of that for feeding for both dairy cows, beef cows, as well as dairy and hogs and poultry. One of the big things that we have in our area is we have a recycler that will go and get outdated food products. Our example here is Coffee Mate. Coffee creamer it's still good, however, it's out of date, and so that cannot be added to or given back to the consumers. Or maybe a formula was quite off and they couldn't fix it, so it could be packaged. All of that ends up in a landfill or somewhere else. And studies are showing that 40% of all the food produced in the United States isn't even used. It's just discarded or put into landfills. Well, our dairy cows can use these, and beef cows as well as hogs can use some of these byproducts to feed and enhance them. And what we found is when we put some coffee creamer into our mix, that increased milk production as well as fat production, which outweighed the cost of bringing the coffee creamer in. Different regions of the United States have different byproducts that are relevant to the dairy industry. They feed orange peels down in Florida, and then out in California, surprisingly, they use the almond hulls to feed to the cows as a byproduct, and those are high in protein and very good for the cows. So what our cows produce milk, which we make into cheese. We also make cheese on our farm, or we sell the rest of the milk to a cheese factory that makes Swiss cheese. And what we're finding out is manure is the best fertilizer to be using. And we do not spread it on top of the ground. What we have here is it's injected, it goes through the hose, and then it's injected into the field where it adheres to the soil. Those micronutrients and microorganisms start adhering right away and breaking down, because manure is only valuable once it's broke down. If it's fresh out of the cow, the crops can't grow in as well, but we get it broke down, we get it working with the soil, and with that, it adheres and it keeps the soils going, and it's great organic matter that makes the soil health much better for the soils. So here's another test of part of the soil samples that we do. And this is looking at organic matter or phosphorus. It makes it more ready, available. It brings in the micronutrients. And so this can tell us where we need to apply more manure, less manure, or other micronutrients that go into the soil to make the soil better and make it more productive. So, and again, that's another level of that precision agriculture that you hear about. And when I was growing up, we used to spread manure over everything. Well, now we can tailor it so that the benefits will go to the one part that makes the most sense for the land, for the water, as well as for our finances. So when it comes to the sustainability of agriculture, again, how circular it is. We feed the cows produced from the crops that we make on our land. We consume the byproducts from other processes to feed the cows. The cows produce manure that we apply to the soil, as well as the milk or meat that the consumers produce. And then we go again and grow the crops to feed, utilizing the CO2. So changes in agriculture that I've seen in my life is when I was growing up, we tilled the soil about 5 times each year in order to grow the crops. We tilled in the fall, and then we tilled 3 times or so in the spring before planting. And then we also used to field cultivate, or we used to cultivate the crops once they were growing. Today, we till our land once every 2 years. And the reason we till is because of the manure. We incorporate that into the soil before we plant. But in the most part, we're very typical, and farmers that aren't using fertilizer can go in a total no-till cycle. So as you can see, just by the reduction of tillage, we've reduced our methane gases, and the efficiencies of the cows themselves have made a big difference. We're producing 30% more milk with the same amount of cows than we did just a few years ago. And through the genetics, we can continue to make the cows better. Through using artificial intelligence, we can hone our processes down and make our cows more efficient, and in the end, be more comfortable for the cows. And again, I'm Joan Maxwell, and we're located in Eastern Iowa, and you can find us on tourmyfarm.com and see more about what we do here at Cinnamon Ridge and what many other dairy farmers are doing. Thank you for your time.
Thank you, Joan. Again, please put your questions into the question and answer box as we start to get some more. We do have a question in, and it's kind of multifaceted. So let's kind of break it up. First, it says, Frank, thank you for your presentation. What can we do to share this progress more broadly? The conversation around greenhouse gas and the environment seems to place a lot of blame on agriculture. I'd be curious to see your slide comparison on the environmental impact of switching to a plant-based or vegan diet. So, and then also, I'll just hold that for a second, Dr. Mitloehner, and what are the impacts, the environmental impacts, but then also asking Dr. Slavin to address the impact on human health. If you know or can address, either of you, the retention rate for vegans staying on a vegan diet, and all of that stuff. So as people, especially this month with Earth Month, and people are thinking, oh, we'll just have a meatless Monday, or everybody, we should get rid of all the animals, from all of you, and Joan as well. Let's talk about the impacts. Why is that a good or not a good idea?
So colleagues have actually answered this in a publication that came out in the Proceedings of the National Academy of Sciences. And they looked at what would the most extreme dietary form, and they chose veganism, to the current one be with respect to environmental impacts, particularly climate. What they found was that because All of animal agriculture combined produces about 4% of direct greenhouse gas emissions. A complete switch of the entire nation to a vegan diet, just theoretical. We all know that that would never happen, but just theoretical. What would that do to our climate impact? And what they found was that it would lead to a 2.6% reduction of greenhouse gases in the United States. So 330 million Americans were to go totally vegan, 2.6% reduction of greenhouse gases. If the nation were to use the Meatless Monday approach, it would lead to a 0.3% reduction of greenhouse gases in the United States. So it's not nothing, but I think most people would agree it's certainly not what it's tooted out in some parts of the media as a game changer. It would not be a game changer. What would be a game changer would be if we were to forego the use of fossil fuels. And that's a big, big goal that is also very difficult to achieve. So really, how do we share this information with others? Well, I've presented it to the United Nations FAO, the Food and Agriculture Organization, which has since deployed a global task force of 65 experts to show whether or not what I proposed is real. And the report will come out in 2 months and show that it is real. And I think that we will have to rethink methane and present it to the public and interested influencers in different ways. We'll do our best to be part of that. It will change the narrative around livestock and climate.
Dr.
I
Slavin?
would like to jump into, I really appreciate having this group together that come from different places, but are still kind of on the same topic. So I appreciate Midwest Dairy for sponsoring this because of that. But I also believe that if you look at people that are vegetarians that are eating dairy, their diet is very good. So I think that's the other problem, like going to a vegan diet, there really isn't enough protein and there are a lot of nutrients that are deficient there. So I don't see that as a, but I do think it's good to do these models because otherwise people just assume that cows are like and methane is so terrible. So I appreciate people saying, hey, wait a second, it's not just ruminants. And, I work in the fiber world and also humans make methane. So we don't seem to be beating up on them and saying every human that comes on earth is burping out methane too. Let's get after them. So I think that's the bringing people from diverse backgrounds together is incredibly important because nutrition people tend to be in the nutrition silo and just, worry about one fat or one sodium rather than the feeding people around the world. So I just think it's good that, and just learning different people's way of measuring things. I really appreciate Joan's point too, because growing up on a farm, plants and animals are not in conflict, they're working together. And so this kind of circular thing that we take the manure and that actually is the fertilizer we have. I thought Frank's point too, just on the size of dairies and all these things, as things change over time, that if we want to reduce, obviously all of these numbers are going to be part of the solution rather than one solution. So was very helpful to see that in California. And if we agree, we're part of the problem, we will take our steps, but we don't have to take, it doesn't all come back to us. People need to stop driving cars too.
Joan, do you want to add to the conversation? Any thoughts?
There is, of course, always the unintended consequences of making changes, especially with the diet. And, some of the things that I brought up, which is the byproducts of the various animals that eat things, is, okay, what happens to these byproducts if we're not going to be using them in animal feed? What is happening to the soybean meal that goes through? The other side of it that we see is how valuable the manure is to creating the food that everybody eats, and it's better for the soil. Well, how are we going to get, if we remove the animal agriculture piece to it, are we going to have pastures where we raise horses? There's always these, if this, then what happens, which we deal with quite a bit. And sometimes it's intentional, and some things you didn't even know it was going to happen when you changed a practice.
We have another question in the box, and I'll ask it, and then whoever would like to, or multiple, can respond. Can you discuss the amount of nutrient loss during pasteurization? That is a FAQ when recommending dairy as a nutrient-dense food.
I'll start, but I wouldn't consider myself an expert. My impression is that people assume any type of processing is going to drop all these nutrients down, but in general, it doesn't have much effect at all. So it's not going to affect proteins, not going to affect vitamins, not going to affect minerals. So my impression would be it's very minimal.
My comment to be on this part of it is unpasteurized milk lasts for about 3 days, and then it starts to sour. So I think by going to more unpasteurized milk, there's this trend out there with homesteading of the unpasteurized milk, is that we're going to create more food waste with this. And then what did we just save by the nutrients if we're discarding all of this? To me, that's not a very wise use of our nutrients and inputs.
I totally agree, Joan. I think pasteurization and any kind of preservation of food is extremely important. We are currently wasting between 30 to 40% of the food we grow in this country and throughout the world. And all means to reducing those numbers would be highly appreciated, not just from a nutritional and food security, but also from an environmental perspective.
And also just the whole food safety thing. People just have no idea, because the food supply in the US for sure is so safe and so protected because of the regulations that have been out there. So food safety, once people decide they don't want processing, they don't want pasteurization, that's putting lots of people at risk.
Mm-hmm.
And for clarification, the opposite of pasteurized milk is commonly called raw milk, just so we all are on the same page. Very good. There's a question, Dr. Slavin, regarding the dietary guidelines. You said you mentioned that they hadn't changed much over time, and the person says they felt that they have always promoted plant-based diets. If you look at the old pyramid or the new plate, fruits, vegetables, whole grains have always been the foundation. Is there something why isn't that part of the new conversation? Plant plus a complete protein, and what do you anticipate in the next guidelines for 2025?
Thanks for that question. I found it's really hard to go back and have people that are classically trained. You know, I'm a dietitian. I grew up in extension. That was my first job, trying to translate information. Took a lot of food chemistry at the University of Wisconsin, learned a lot about food chemistry. And I find that there's a real lack of people don't really understand what's in food. So this idea that this is good food and bad food is kind of always out there. And right now, animal food is bad and plant food is good, but people don't understand at all the nutrients that are in there. So as we move to dietary patterns, it's a good idea. But, you know, going back and saying, we have to get these nutrients. We absolutely have to get these nutrients. So, you know, I had a question, and it had to do with somebody called me and said, hey, let's make cabbage. We can take cabbage and make it into protein. We can take these products that are really low in protein and take the protein out by processing them and then sell that as protein. That's such an inefficient way of getting protein to the masses. I mean, that's the amazing thing about eggs and milk. All these things are really high in protein, and the protein is really high quality. So I find that's basically, you know, besides the fact that people just, they you know, assume that a plant-based beverage or milk that they want to call it is comparable. It isn't at all. It doesn't bring any of the nutrients along. The protein isn't there. So, you know, and just the fake, I find it also bizarre. If you want to be a vegan, then why have fake hot dogs and fake milk and fake chicken and fake burgers? Just get off of that and eat the plants as they are. So, and I think that's kind of traditional vegan diets too. We don't have to come up with these fake things. So I find that the dietary guidelines do some of the new concepts on processing and ultra processing. They get a lot of, and that's the important thing about dietary guidelines. I always want to encourage people. It's an open process. The process is open right now. As a consumer, everyone can put information into the dietary guidelines. Provide information. It is kind of consumer driven, but it's just a very complicated thing too. But I believe things like sustainability will become more important to dietary guidance, cost, all these other issues, not just nutrients too.
So Frank, a question for you. Knowing that methane is considered a flow gas, where does it go from livestock once it's released into the atmosphere?
So methane is always destroyed after about a decade. So just imagine my fist being a methane molecule. Within floating around in the atmosphere for about a decade, it meets another molecule, and that other molecule, called a radical, a hydroxyl radical, destroys the methane and converts it into CO2 and water. That's what happens to methane. The same does not happen to CO2. The same does not happen to nitrous oxide. It only happens to methane. And that is really important. If we now reduce methane by mitigating it through feed additives or manure management or so, then we are replenishing less methane than is naturally destroyed. And that means we are reducing carbon in the atmosphere, and that reduces warming. And that makes us part of a climate solution.
Joan, I have a question for you. Is there any aspect of your farm that you find would be the most, that you found to be the most influential or impactful in you meeting the sustainability goals?
We don't really have one silver bullet. It's a lot of little things done right. And like I said, it really does start with the soil. That's probably our most sustainable piece of things. The more sustainable we can grow the crops with keeping the soil in its place, minimum tilling, less use of carbon-based fertilizers. We use very little here on the farm. Our manure replaces all of it. And so that piece of it, growing the crops sustainably. The second thing that's been really quite impactful for us is using artificial intelligence to hone in on where to make our cows more efficient. And some of that is with the genetics. I didn't really touch on the genetics. We have a whole group behind us that we use through our breeders to make a better and more efficient cow. Then the second side of it is we're looking at the cost or the use of particular inputs for the cows through what they eat. And we're finding that the less they burp is the more energy that can go into their bodies to produce milk. The hypothesis is each time a cow burps, that's lost energy. So looking with that and working with Juan Tridic, I get his last name mixed up, Tridic through US Dairy Sustainability. And he's really looking into that, and that has a lot of information from our nutritionist. And again, simple things like having fresh sand for the cows to lay on makes them more efficient. So the efficiency is huge in the dairy industry. We're using like 30% less water to produce milk. We're using less water to produce the crops that the cows eat, or getting more out of the same on our land. And all of that together is what makes us sustainable.
Dr. Slavin, you talked about some plant-based alternative beverages. I am going to hesitate to refer to them as milk, but plant-based alternative beverages. Can you address those parents, well-meaning parents, adding those to their children's diets and any health implications that might have, other than if it were medical necessary?
Yeah, I'm going to go back to the dietary guidelines too, and this has always been part of dietetics, that, for young children, the amount of nutrients that come through dairy products is critical. Like we are mammals, let's face it, we grow up on milk, and milk provides important nutrients. So I find so often people somehow don't get that. And so, that they think, okay, just really, and just to think about the Canadian where they said just replace water with milk. No, a glass of milk has all those nutrients that we've already talked about. So if you're going to replace it with another beverage that you think is the same, it is so far from the same that it's, we're going to see failure to thrive for children that are using that because it's just not, so 2 to 3 servings of dairy, whether it's in milk or cheese or yogurt, is what everyone needs to get those nutrients. So when we just replace that with something that doesn't have any of those nutrients in it, isn't good. It's not going to be good. And that's the frustrating thing, that people somehow think it's healthy. So that's, and I was going to say, I really appreciate Joan's bringing people onto the farm too, and introducing people to that, people that milk cows and are in the dairy business are incredibly sustainable, and kind of putting, to actually taste the food, to have the cheese, to have the milk is really important, rather than thinking that there's something, and we see it in a lot of products that people eat this versus that, and all of a sudden I'm going to be vegetarian, so all of these vegetarian beverages are somehow better than milk, and on the nutrition side is absolutely wrong.
Dr. Slavin, I have a question for you, if that's
Yes.
okay. So there are places like New York that prohibit the sales of whole milk to kids. What do you make of that?
Well, see, I find it, part of it is you have to remember the dietary guidelines need to reduce calories. So with dairy products, the advantage of milk, low-fat milk, is you get all the nutrients without the calories. Okay, that's fine for somebody that's old and obese. I get that. But for children, especially a lot of cultures, they don't even they won't even consume low-fat milk. So to me, we should never have rules like that. And that's kind of, even when I showed the rules that we have now through the dietary guidelines, no flavored milk, because there's added sugar, those are the kind of rules that make us go down the wrong path. And I know when Joan talked about the unintended consequences of trying to do the right thing, but in the end, if nobody's going to consume this low sugar or low fat beverage, you haven't accomplished anything. So I would totally disagree with that. But it's really hard being, trying to accommodate all these needs too. And that's why I think we need to have choices and say, hey, depending on the person, I always say, breast milk, 50% of the calories come from fat in breast milk. So, there's no reason for a child to be on low fat milk at all. We should never say you can't have regular fat milk. It's, it's the right thing for children for sure.
Mm-hmm. Thank you.
Yes.
Well, Dr. Mitloehner, you had the last question. Thank you. If any of you are wondering and maybe didn't catch the answers to the questions we posed earlier, what percentage of the U.S. greenhouse gas emissions come from agriculture? It is 11%. And the second question, in regards to how many, what a serving of milk provides as far as how many nutrients, it is 13. And that number has changed in the recent years. So it's pretty exciting. Thank you everyone for being a part of today's webinar. This concludes dairy's role in a sustainable, healthy food system. And we hope this information provides you with context to educate others on dairy's role in the food system. As a reminder, any continuing education credits, certificates and the presentation slides will be emailed to you following this webinar, along with a post-event survey, and we'd love to hear from you. Again, a recorded version of this webinar will be available in the coming weeks at midwestdairy.com.